So the next logical question would be, well, what if we needed to go the other way? What if we needed to find a z-score that corresponded with a particular area? So in this case, we're talking about a z-score that represents the 90th percentile. So what I'm going to do is pretty much what I did before. Start off by drawing a diagram. I'm going to ballpark where 90% is. I have no idea. So I'm just going to wing it. Why did I put it here? I don't know, because it looks like it's 90%. All right, so the function in the calculator that we're going to use is the inverse norm. So I'm going to type in inverse norm .9, the mean, and the standard deviation. So second vars, option 3, 0.9, 0, 1. Some of the more advanced calculators have a wizard that go along with this, where you still put in the area, but it gives you an option to select area to the left, area to the right, area between. So this is always assumed to be area to the left of a z-score when it's in this notation. Oops. I don't know why I opted to go script there. So we're looking at z being approximately 1.282. We actually used to have to do this with reference tables, but we have technology now. All right, so next up, Q3 is the same as the 75th percentile. Again, no idea where it is. I'm just estimating. Draw a little sketch here, a little scribble scrabble. .75, 0, and 1. And so we're looking at approximately 0.674. You'll notice how it doesn't fully correspond to the diagram I drew, but that's because going in, I didn't know where the z-score was going to be. All right, so I just went for it. I knew it would cover about, well, I knew it was going to cover more than half of the graph, but that's all I knew. All right, so you can't be wrong when you're drawing a sketch, even if you label it with tick marks. Now, the next set of problems is really virtually the same as what we were doing previously, except now we have x values instead of z-scores. All right, the calculator handles it exactly the same way. All right, so the only difference is, so I guess when I point out differences, it means that it doesn't exactly handle it the same way. I just learned a little nifty shortcut there. The difference is going to be in the graph. All right, so instead of being centered around 0, it's going to be centered around 143. So our tick marks would be in increments of whatever the standard deviation is, in this case 29. So 172 would be my next tick mark, and 201 would be the one after that. So 150, just all eyeballing it here, like between meh and meh. So we're looking for this sliver. All right. In terms of the approach, that's where it's exactly the same. So it's still normal CDF. When I'm looking for areas, it's normal CDF. Min max 150, 180. The mean 143. And the standard deviation 29. All right, so second var is option 2, 150, 180, 143, and 29. So we're looking at about 0.304. In terms of a percent, roughly 30.4% of the population would fall in that category. We'll learn what this means in terms of drawing conclusions down the line, but for now it's just another percentage. Cutting off the top 25% from the bottom 75%, this is the same as saying the 75th percentile. This time I'm looking for an x value, but it's still related to 75, so inverse norm, 0.75, the mean of 143, standard deviation of 29. All right, so second, vars, option 3, 0.75, 143, and 29. So we're looking at about 162.56. All right, these are not standard units, so these would actually have units, in this case pounds. All right, but although it's not stated in the problem, so for this, if this problem came up on a test or a quiz or something like that, you'd be off the hook because it didn't indicate the units. Now, it's not likely that we're talking about kilograms. However, you never know. All right, so there it is.